Some reactions occur faster than others, whether it is the combustion reaction of methane producing carbon dioxide and water, which is a very fast reaction, a very rapid reaction, or the conversion of graphite into diamond at extreme temperature and pressure, which is a very slow reaction. Here, this tells us how different chemical reaction occurs at different rates. Today in pharmaceutical chemistry, we are talking about chemical kinetics, which is rate of reaction at pharmacology made easy. Now, from our balanced chemical equation, we know that we have the reactants and the products, and the reactants collide to form the products. Yes, as you can see from this picture, we have Na plus Cl producing NaCl. Na plus Cl, which are the reactant or the reactant species, and we have the product form, which is NaCl, common salt. Now, when A plus B gives C plus D, A plus B being the reactant, C plus D being the product, the rate of reaction is directly proportional to the concentration of reactants. Since concentration of reactants decreases and more of the product are formed as the reaction progresses, this means that the rate of reaction decreases as the reaction proceeds. That gives us the formula delta C over delta T, change in concentration of either the reactant or the product over change in time. Note that concentration is denoted by the square bracket. Now, from the law of mass action, we have the reactant species and their coefficients or their molecules. It states that the rate of reaction is directly proportional to the product of the concentration of the reactant raised to the power of their exponent or their index, of which K is the rate constant, and any change in factors affecting reaction rate like temperature, catalyst, pressure also leads to a corresponding change in K. Now, how do we classify rate of reaction? We can classify them in two ways. The first one is molecularity. This is the number of molecules of reactants or molecules of reactant species. They may be unimolecular, which means having one molecule of reacting species, like the reaction below, bimolecular, like the reaction of hydrogen iodide below. We have unimolecular, bimolecular, and thermomolecular reaction, using molecularity to classify reaction rates or rate of reaction. The next step to classify the rate of reaction is by the order of reaction. This is the sum of the exponents of the reacting species. A plus B leading to formation of the product. From the law of mass action, we can write out the formula, and the order of reaction is equal to A plus B. It can actually be first order, zero order, or even second order. Now that you have learned the basics, solve this question using the reaction rate formula. What is the rate of reaction if the concentration of a reactant decreases from 2 molar concentration to 1.5 molar concentration in 10 minutes? Use the hints that the unit of your rate of reaction can be in molar concentration per unit. Solve this question, comment your answer below. On our next video, we'll be talking about order of reactions and its calculation, first order, second order, and so on. If pharmacology was made easy, kindly subscribe, share, like this video for more pharmacology content, pharmaceutical chemistry, pharmacognosy, and pharmacology in itself. Thank you.